Okay, today we're talking about piecewise functions. A piecewise function is a single function that uses different equations to find y values based on different x values. And it works kind of like an if-then statement. So we'll see an example of that in a second. But first, to talk about things we're going to need today as we graph some of these, we'll be graphing them a lot, is how to graph things in slope-intercept form, y equals mx plus b. Remember, b is our y-intercept, and that m is our slope, or our pattern our line will follow. We're also going to be graphing constant functions, so y equals a number, like y equals 5, y equals -4, which will result in a horizontal line. So let's take a look at an actual piecewise function. Okay, so the way this works, and I'll go ahead and throw the graph of this function up here as well. Okay, the way this works is we're going to have different equations that we're going to graph for y. So remember, f of x is the same as y. But we're only going to graph this equation, which is a linear equation of a line, y equals x minus 1, for values of x that are less than or equal to -1. So you'll see that's this line here, and we graph it all the way up to the x value of -1 and including -1. So we're putting this closed dot to show that equal to bar. Then it's going to change. Instead of graphing that line for any value past -1 to the right, it's going to switch to this parabola x squared. So you can see it's got our parabola here, switch to x squared. You guys won't have to be graphing those yet. But you can see that -1 is not included when we switch to this graph. And so we use that open dot to show that that point is not included. So that'll be important as we go through some of these other examples. So I told you these were kind of like an if-then statement, so just to show you how this would work. And if-then statements are very important in programming. If something is true, then perform this action, or then do this. So we're kind of saying if this part is true, then graph this. So if this is true, then do this. You could also think of this, graph this equation for values of x. So you could think of it as a for statement, which is also pretty big in programming. But that's kind of how these work. Okay, so we have some steps for graphing piecewise functions, and we have an example down below we're going to follow as we go through these steps. So the first thing to do is identify breaks in the domain, the x values where the graph will change equations. So again, if x is less than -3, then graph y equals x plus 1. If x is greater than or equal to -3, then graph -2x plus 3, y equals -2x plus 3. So where are we changing from one equation to the other? Where do we have this kind of break in our domain? And that's for the x value of -3, so right here. Okay, step 2 says, now that we've identified the breaks, or in this case singular break, graph a dashed vertical line at these values. And this is just going to visually separate our graph into two different regions. Okay, so we're going to graph in our dashed vertical line. Okay, that's where the break in our domain would be, and the dash part means it's not technically part of our graph. Okay, then graph each subfunction, that's what we call these different parts, in its appropriate region. Use the inequalities to identify the correct region. Okay, now generally if these are written correctly, it should be top to bottom goes left to right. So hopefully this is in the correct order. Okay, so let's start graphing these. I know our first one here is in y equals mx plus b form, where b here is our y-intercept. So let's switch colors. So my y-intercept is at +1, and our slope, it looks like, is 1, or 1 over 1. So that's positive means up, and positive means to the right. So up 1, right 1, that's our pattern. We can use for our line here. And of course, following that pattern is down 1, left 1. So I'm going to skip over that part of intersection for now. Okay, so this would be that full line. But I don't want the whole line. I only want it for values less than -3, which would be values to the left. Is it allowed to equal -3? In this case, no, it doesn't have that equal to bar. So the way we show that is where it intersects this is we're going to do that open dot. Okay, so I'm going to try to use the line tool so it looks a little bit nicer here. And then we're going to follow through our pattern, something like that. Okay, and all these extra dots that we put in there are really unnecessary. You could go through and erase them. Okay, so I went ahead and erased that extra parts we didn't need. Let's graph our second part, which is also in y equals mx plus b form. This time our y-intercept is at 3. And my slope we can think of as -2/1. So down to right 1 to continue to our next points. Okay, so this is the pattern of this line. And if we wanted to continue it, it looks like it would intersect here. And in this case, it is allowed to equal this value -3. So we're going to put a closed dot there. And then to graph our line in, use the line tool to be a little bit nicer. And of course, we should be putting also arrows on the one side that's going to continue forever of each of these. So I'll do that for my 2 graphs here. And that's it. If you want, you could erase the green domain break. It's not technically part of the graph, but it was a nice visual guide to help us remember where we're stopping one of these and starting the other. Okay, let's do this second example. So same idea. First thing again is we're going to identify our domain break by looking over here at our if statements. So it looks like we're graphing one when x is less than 1 and one of them when x is greater than or equal to 1. So +1 appears to be the value where my graph is going to change from one and switch to the other, or stop one and start the other. Okay, so again, let's start top to bottom here. This should be to the left of our region. Y equals mx plus b. In fact, it looks like the exact same line we just graphed a second ago. So y-intercept of 3. Let's get a color here. Y-intercept of 3. And a pattern of down to right 1, down to, whoops. In fact, at that intersection, because it's not allowed to equal, I'm going to go ahead and throw in my open dot. Again, you can tell it's not allowed to equal because my inequality statement does not have the equal to bar like the one below it does. So of course, continuing this pattern would be up to left 1. And I only want this line for values of x less than 1. So less than 1 means to the left. So I only want the part of this line that would continue from here to the left. Okay, so I want this part, and if we want, we can erase the rest. Okay, so I went ahead and erased the extra dots there for you. Looks a little bit nicer. Let's graph our second one, and now we're finally graphing our first constant function. This is really just, remember, y equals 6, -6. So in fact, this is a horizontal line where y is always -6, but we only want this line for values of x that are greater than or equal to -1. So in this case, even though the line itself would go in both directions forever, we only want the part of it that's going to go to the right forever, and we could erase whatever would have gone to the left. So again, if you wanted to, you could erase the green line here to show that's not technically part of the graph, but as long as it's dashed, you're fine. You can leave that in. Okay, this next example has 3 different equations to graph. Okay, and this could keep going. You could have lots more than that. But again, we're just going to go through our steps. The first thing I want to identify is over here, where do I have a domain break or domain breaks? And just looking at these values, I can see at -2, we're going to have a domain break. So I might go ahead and graph that in. Okay, and then also over here at 3, I have a domain break. So I'd want to graph that in. Okay, so now I want to start graphing my equations here. So we're going to graph y equals 3, which would be a horizontal line at y equals 3. But I only want it for values of x less than or equal to -2. So this horizontal line, I only want values that are less than or equal to it. So I only want the part of it that's going to go that way. Okay, for our second equation, I'm just going to stick with the same color here, is -x. So this, in fact, is an equation of a line. You can think of that as negative x plus 0. So my y-intercept is 0, and my slope is down 1 over 1. So if I started here, down 1, right 1, down 1, right 1, looks like we're going to have open dots. So I look at this, it's not allowed to equal either of these, so open dots at both intersections. So open dot there. And in fact, I only want values between -2 and +3. So in fact, I'm going to be kind of stuck in between my two domain breaks, okay, with an open dot on each. Lastly, we're graphing this line, which has a y-intercept of 1 and a slope of up 1, right 1. So up 1, right 1, up 1, right 1. So we should have something that follows this pattern, but we only want the part of the line where x is greater than or equal to 3. So equal to means closed dot, greater than is only to the right. So we have this kind of... Okay, this next one's asking us to write the equation of the piecewise function graphed below. Okay, so first thing I like to do is look for these domain breaks. Looks like we're definitely changing from one equation to another there and right here. So it looks like we're going to have to write 3 different parts, one for each of these 3 different equations. So let's start from the left. This looks like a nice equation of a line, maybe mx plus b. And if I did follow that pattern, which appears to be, looks like up 1, right 1, so we'd have a nice slope of 1 over 1x. I guess I should write this over here where this equation is. So 1 over 1x, there's my slope. And then my y-intercept, if I continued that pattern, would be at 0. Okay, so cleaning up my equation, this would really just look like y equals x. And we're graphing that for values of x that are less than or equal to, so we graph that for values of x that are less than or equal to -1. It does have a nice closed dot there. Okay, now we have this section in the middle. And so let's find the equation of this. Looks like, again, my slope pattern is kind of up 1, right 1. So we'll go ahead and say our slope is 1 over 1x again, but this time my y-intercept is 2. So now we want to graph the line, simplifying that to x plus 2, but I want that for values that's between -1 and +1. So always put the lower boundary furthest to the left, the upper boundary furthest to the right. We're going to put x in the middle. And I notice it's not allowed to equal -1, so just less than. And now here we have a choice to make. Underneath this dot, because these two end up connecting at this domain break, we can really choose which one has the open dot, which one has the closed dot. Even if they overlap, it doesn't really matter. So I'm just going to pretend this is maybe an open dot at -1 on this line, and it'll be closed on our other one. It doesn't really matter since that point is overlapping. Okay, we're almost done. Lastly, though, we have this line y equals 3, this nice horizontal constant. That's not a 3. Y equals 3 for values of x greater than or equal to 1. Okay, as long as one of these equations is allowed to equal +1 so that there is a closed dot on my graph, we're good to go. But the choice there is yours. It says an air conditioning salesperson receives a base salary of $2,850 per month plus commission. The commission is 2% of the sales up to and including $25,000 for the month, and 5% of the sales over $25,000 for the month. Write a piecewise function that relates the salesperson's total monthly income based off of his or her sales for the month. Okay, so we're going to write a piecewise function. So since it has to do with income, I'm going to use I of x. We're going to let x represent sales for the month. Okay, so it's a piecewise function, so we'll have our big squiggly bracket I can't draw. And then let's try this. So let's see, they get a base salary of $2,850 per month plus 2% commission. Okay, so anytime we're going up to and including $25,000. So this shouldn't be too hard to write. They're going to be at $2,850 plus 2% of 2% of their sales, we'll say. So to find 2% of something, you would multiply it by its decimal value, 0.02. And since sales is x, 0.02 times x. However, we only use this equation when my sales, in this case x, is less than or equal to, because it's up to and including 25,000. Okay, so that's going to help me figure out my income if I sold $25,000 or less. The next part's where it's going to get a little bit trickier, and I like to say try this out by doing an example. It's going to help us come up with this equation a little bit more. Let's say we sold $30,000. Okay, so I sold $30,000 this month. So I've gone beyond this $25,000, and now we're going to start to get 5% of the sales that are over that. Okay, so let's just see if we can figure out what I would have made. Okay, so first of all, I know I get my $2,850. I know I'm also going to get 2% of the first $25,000. So let's figure out what that would look like. So 2% of $25,000, okay, is $500. So we can add that on. So if we add that on, I know I'm going to make $500 extra off of the commission of the first $25,000. But then I get 5% of the sales for any amount I go over. So I don't want to do 5% of 30,000. I want to do 5% of what we went over, 25,000. Of course, I went 5,000 over, but a way of calculating that would be to subtract the 25,000 out of there and figure out, yeah, we went 5,000 over, and now I need to do 5% of that amount. So of course, if I did do 5% of that amount, 0.05 times the $5,000 we went over would give me another $250. Okay, so then we could add on 5%, I guess I should say, of the $5,000, and that gave us another $250. Okay, so let's try to make sense of what we did here. So because we went over $25,000, we're definitely going to make this $500. Remember, this represented the 2% of $25,000. So we can go ahead and tack that on here to our $2,850. And if we add these together, we should get $3,350. Okay, but I don't want to put just 5% of X, because X would have been the total sales. That would have given me 5% of 30,000. That's not correct. I only get 5% of this difference, how much I went over. So our second part of the equation, I told you this one's a little more complicated, isn't 5% of X, it's 5% of whatever X was minus the 25,000. Okay, so remember this has the extra $500 built in of this 2% of 25,000, and then we're getting 5% of what we went over. And we're going to use that equation when X is bigger than 25,000. If we sold more than 25,000. Okay, there's our first part. Okay, now that we've set up this complicated looking piecewise function, determine the salesperson's monthly income if his or her sales were 43,000. Okay, so now we're using this. If we're going to plug in an X value of 43,000, which one of these equations would I use? Is that less than 25 or greater than? Well, it's obviously greater than 25,000, so we want to use the bottom equation here. So we would plug in 3,350 plus 5% of 43,000, 000, minus 25,000. And this should give us our answer. So if we want, we can go straight to the calculator. 3,350 plus parentheses 5% of, I guess I didn't need parentheses there yet, but that's fine, 43,000 minus 25,000. And there we go. It looks like $4,250. is how much that person made that month. Not too shabby. Might start selling air conditioners. Okay, last one says determine how much the salesperson sold in a month. So now we're figuring out X if their total monthly income was $3,210. So we're going to have to be smart about trying to figure out which one of these equations we want to use. So remember we said if they sold up to $25,000, that ended up tacking on this extra 500 over here. And that gave us the $3,350, right? So if they sold over $25,000, they've made a minimum $3,350. So if we compare that to the amount they gave us, it doesn't look like they sold that much. They didn't make this minimum of $3,350. So I'm going to say we're going to have to use the top equation this time. So if we're using this top equation, we know that their income, so this is what we're going to replace over here with y, was $3,210. And when does that equal our equation here? $2,850 plus 2% of their sales. And we're trying to find their sales this time. So of course we're going to subtract our $2,850 over. Use our handy dandy calculator. 3210 minus 2850. Okay, gives us 360. And so we have 360 equals 2% of sales. And now to finish getting x by itself, of course we need to divide by that multiplier of 0.02 on both sides of the equation. So 360 divided by 0.02. 18,000. It looks like this person sold, get rid of the calculator, $18,000 that month. Not too bad. Didn't quite get over that big threshold, but $18,000, not a bad salesperson.